So write trajectory of a marble. Okay. What you're going to do is you're going to have a ramp. The marble is going to roll down the ramp. And the first exciting part of this lab is that you're going to use some distance here and a stopwatch, right? And you're going to predict, for part one, you're going to calculate the speed of the marble. Is this possible? Well, it is possible if your marble doesn't go too fast and you let it roll a long, long way. If you don't make it go too fast and it rolls a long way. So I'm going to use, I think this ramp is too high, so I'm going to use something like this. Okay? And you could use a book or a notebook or something like that. And we've got this nice ramp, and you can see that right here I put a little bit of tape there, and the tape helps the marble not bounce. Also keeps your ruler, and that's really all you need. It keeps your ruler from moving around. And you're going to take the marble and roll it. It's going to go across the counter, and it's going to roll off the counter, and then we think it's going to obey the laws of physics, or we have a reasonable suspicion that it will, right? Now, how can I measure the speed with which it leaves the edge?
Keep your folder for gift wrap.
I don't.
No? Okay.
I'm sorry.
All right.
I never have it, but I will have it. Someday I will have it, and it will have money in it. Okay?
Where is it?
I don't know, but that's okay. The money is the important thing. Okay, how can we measure the speed?
By
Timing it and
distance.
distance and using a formula that says distance, speed is distance over time. Is that what it is?
That's exactly what it is.
Yeah, that's what it is, right? So what you're going to do, literally, you're going to take your stopwatch here, and it really helps to have two people. When do I want to time it? While it's speeding up, or from when it hits the counter to when it hits here? Yeah, just the counter. Don't time it while it's speeding up. It's much, much easier, because then it's like it's sped up for part of the time and it rolled at a constant speed for part of the time. All right? So when I do this, I want to go from there to there. And hopefully it isn't going to bounce off of something, right? Okay? So time that, and it should be some amount of time. If it's a steep ramp and a short thing, you're going to be so inaccurate. But if it's about this distance, this is about right. Okay? So measure this distance, take a ruler and measure what this is. Make sure you convert everything to meters per second, because that's what we've been using. So this is, for example, 0.68 meters, right? Okay? And then, do we also need to know the height of the table? Yeah? So measure that. You need to have the height of the table. Okay? And then you ought to be able to calculate this, right? So what you're going to do is you're going to roll it down there. Do many trials of it going across. Always release it from the same spot on the ruler. This one's not following. This must be like you'll find the countertops out there will be a little flatter. I think this little bit of countertop is not very flat. You'll find that out there they'll more or less go straight. Okay? So do many, many trials. Don't let it hit the ground, because that spoils it, right? Do many, many trials to figure out the velocity, and the velocity is just simply going to be the distance. I'm going to call that x1, okay, divided by t1, and t1 is the time it takes literally to cross that counter. Okay. Now what's next? Well, of course, what we want to do is predict where this thing's going to land. So once it rolls off the table, it's going to hit some distance here. And notice this is somewhat tricky, because the counter actually sticks out a little bit, right? It sticks out some amount. Then it comes down here, and then, of course, it goes in because there's a little kick plate like that. So you're going to have to somehow figure out exactly what point on the floor is directly below the edge of the counter, kind of IQ on the line. I know, it's a lot to ask. Okay, so we're going to figure this out. And then the thing that you're going to figure out really in our formulas is this distance here. So I'll call this x2. Okay? Very confusing. So just separate it in your mind. Keep it separated, right? There are two parts. The first part is figuring out what this velocity is. Okay? That's part one. Okay? Part two is just a cliff problem like you've normally done. Horizontal, vertical, x, vi. What are we going to know in this problem when we solve it? Yeah, the accelerations, we think this will be 0. This will be negative 9.81 because it's Earth. What else?
We know that the initial vertical velocity.
Yeah, we think that this guy will be 0 if they put the formica in here, okay? Which, by the way, that's an Italian word, isn't it? Formica. Yeah. We had a kid here whose last name was Formica. What? It's what? I'm not understanding the word. Oh, it's an insect. It's a bug. It's a bug. There we have it. I got it. All right. All right. Okay. And then what else are we going to know? Yeah, displacement. This is something you're going to have to measure, right? Okay. Also, make sure that it's in meters, not centimeters. So kids will like say, "Oh, it's 94 meters tall." Well, that's a big counter. It's probably 0.94, right? Okay. So do it in meters, not centimeters. Put that guy in there, right? And then the way it's going to work, it's just like the problem you solved. You're going to figure out the time. Time will go across, and then you know this velocity here is what you're going to put in there. So the thing from part 1 is what you're going to put in for part 2. Okay? And if it's way too confusing for you, for the part 1, part 2, I don't get it, right? Just do the first part, figure out that velocity, and go. And I'll come over and I'll explain how to do part 2. Okay? But the self-directed among us ought to be able to figure out the velocity, then do this, figure out where it's going to land, then what you do is you take your target cup and you measure that far away. You go down here on the floor and you say, okay, it's going to land 17 centimeters away. So you find 17 centimeters, you put the thing there, and you have a drum roll. Somebody has to do a, right? You roll it down the ramp, and it lands right in the cup. Or maybe not, especially if you thought that it was 94 meters tall. Are we good on that one? Okay. On these ones, feel free to work in groups of 2. Okay. That is pairs. That is pairs. Okay. So 2 people are going to share the same numbers. If the computers are busy, then work on the Marble Lab. And if the Marble Lab is busy, then work on the computers.
Isn't this the Marble Lab?
This is the Marble Lab, yeah.
So then what are you telling us before the Marble Lab?
The computer lab, the Vernier lab. I know. It's too much, I know. Okay. I know. And then one word of caution. The computer over there, we don't know why, but the one to the south of Alish doesn't run the Vernier thing. We don't know why. I've reinstalled it, restarted. There's some piece of software that conflicts with it.